weather patterns. Okay, so we've been talking about climate, and now we're going to head to weather. So the first thing we're going to look at is a high pressure system. A high pressure system is a large body of circulating air with high pressure at its center and lower pressure on the outside. Please make a note in your notes that a high pressure symbol is a blue H on a weather map. So please write that in your box within your notes of the high pressure system. Okay, weather effects. We have sunshine and good weather, dry, high day and night temperatures, dew and frost, fog and mist. So these are all fair weather skies. So high pressure systems, I would say, we like that type of weather. Doesn't bring a lot of precipitation at all unless you have it mixed with a cold front. A low pressure system is a large body of circulating air with low pressure at its center and higher pressure on the outside. Please make a note in your notes that it is a red L that you will find on a weather map. The type of weather that a low pressure system brings. It brings clouds and precipitation. It is windy, has milder temperatures for the time of year. So typically if you have negative temperatures for that time of the year, it won't be that harsh. However, it's very changeable weather like what we have here in Ohio. It seems a lot. Air masses. If you look at the picture, the air masses are large bodies of air that have uniform temperature throughout. Looking at those symbols, we have CA. CA represents continental Arctic. So if you remember, we talked about being classified by where they are formed. So if they're formed over water, they're called maritime. If they're formed over land, they're called continental. So maritime is the water aspect and continental is the land. So the second thing that they are classified by are their temperature. So if they are warm air masses, they are called tropical, and if they are cold, they are polar. So looking at those symbols, we have MP. MP stands for maritime polar. So you mix the four terms, maritime, continental, or tropical and polar, to describe the different air masses. So in the continental United States, we have air masses that move from the prevailing westerlies, which is caused by the jet streams. So if our weather is coming from the northwest, think about the northwest is Canada, Alaska, it's going to bring down some cooler temperatures. If our air masses are moving from the southwest, however, it's going to bring up warmer temperatures and maybe a little bit more moisture. Okay, you have a table in your notes that in the first box, it has your term and some information. In the second box, underneath the definition, I want you to draw the picture of the front, okay, in the second box, not in the blank box, okay, because in the blank box, you're going to be adding, what weather these type of fronts bring. Okay, so first off, a cold front. Cold air is going to move under a warm air, forcing the warm air up. The symbol is a blue line with triangles that are facing the direction that the front is moving. A warm front moves slowly and brings warm, humid air. It is a red line with red half circles. The circles are pointing in the direction it is traveling. Stationary front. It forms when a cold mass meets a warm mass, but neither have enough force to move the other. Stationary means stand still. So this front is going to stand in a place for a long period of time. Occluded front is a warm air mass caught between two cold air masses. So the symbol is a purple line that has on the same side alternating purple triangles and half circles. Okay, some more details about these air masses. If it is a warm front, okay, a warm air mass is going to overtake a cold air mass. Some characteristics. It's warming suddenly when passing. You're going to get showers before, light drizzle after. No precipitation when the front has completely passed. You're going to have cirrus clouds. Cirrus clouds form ahead of the front. Now, cirrus clouds are the fair weather clouds. They look like the feather-like. They're really high up in the sky. As the front comes closer, stratus clouds form. Stratus clouds are just a little bit lower than cirrus clouds. These clouds can then change into nimbostratus clouds and produce rain, snow, sleet, and freezing rain. Nimbo stands for storm. Stratus is just a medium level cloud. So you're going to have a storm cloud that's medium height in the air. So look at this picture. You see the red symbol for warm front. The warm front's moving towards the right, so you can see that those circles are pointing towards the right. So the warm front overtakes a cold air front by basically pushing it out of the way. If you see that right red diagonal that's going up to the right, it's showing that the advancing warm air behind the warm front is pushing the receding cold air front. So a cold front, the leading edge of a cold mass replacing at a warmer mass of air. Some characteristics about this. A cold front's going to move a lot faster. It has more drastic weather changes. It's usually associated with high pressure. You're going to have brief showers before, sometimes thunderstorms while passing, and clearing after it has passed. Cumulus and cumulonimbus clouds will form. Now, cumulus clouds are those big puffy cotton ball-like clouds. Cumulonimbus has the cumulonimbus, the nimbus meaning storm clouds. So you have the low-lying cotton ball-like clouds that are dark clouds that form thunderstorms. So this one looks a little bit different. You can see that it's not pushing at that same angle as the warm front. However, cold fronts move a lot quicker than warm fronts. So the symbols are pointed towards the direction of travel. You can see the receding warm air ahead of the front. Okay, a stationary front. It's a boundary between two different air masses, neither of which are strong enough to be replaced. The front is not moving. Some characteristics: noticeable temperature shift from one side to the other, heavy amounts of precipitation, widespread clouds. Now this precipitation is heavy because it's staying still. It's not moving quite as quickly as what a warm front or a cold front would. So you can see in this picture it's showing that we do have the precipitation ahead of the front. No occluded front is when a cold front overtakes a warm front. Usually occurs around a low pressure situation. When this happens, it is very common to have funnel clouds. Now if you remember, funnel clouds are tornadoes that don't reach the ground. So cold and warm air and cool air come together. In a cold occluded front, cold air pushes under cool air, and in a warm occluded front, cool air rises over cold air. So you can see this picture of an occluded front where we have two cold air masses that are meeting in Indianapolis, which is producing a lot of precipitation, strong thunderstorms. All right, so in that last column, in the last column of that table that you have, this is the type of weather that it's going to bring. So a cold front, make sure you write this down in that last column, brings thunderstorms, and as the front moves through, it brings cool and fair air weather will follow. A warm front, it has broader clouds, gentle rain or light snow followed by warmer, milder weather, and usually fog follows. Stationary front, stands still, clouds, prolonged precipitation. In an occluded front, temperature drops, strong winds, and heavy precipitation. All right, so a storm is a violent disturbance in atmosphere called severe weather. Now, you know what a thunderstorm is, you know what a tornado is. Now, imagine being in the middle of summer, we're on a hot, sticky day, and then all of a sudden it becomes cold. Okay, I've been outside, and when you feel that sudden urge of coldness come through, you look up in the sky, and you might see different colors, the pinks and the purples that are coming through. This typically happens towards the end of the day, in the PM hours, but you're going to get these different layers of wind that are causing updrafts. And so when that warm air rises quickly, it's going to form these large cumulonimbus clouds. The air currents create strong updrafts, and the water droplets and ice particles rub against each other. As they bang together, these water droplets up in the clouds, it's creating a lot of static electricity. We've talked about this earlier in the year. That's how you get the flash of lightning. The tornado is going to be produced when you have these layers of wind. You know, the ground grows warm and the air above it's cooler. So like I said, that cold front quickly takes over what that humid summer air brings. So the warm air near the surface is going to rise. And as it cools, you have this layer of cold and warmness creating water vapor. And as this water vapor condenses and the different wind directions start creating that updraft, the thunderstorm will then rotate the vortex and create possibly a funnel cloud. Now this map shows where tornadoes frequently occur. you'll see that in the middle of the United States we have the most frequency. Over on the west coast we have a mountain range, and on the east coast we have a mountain range. So in the middle it's very flat and plain-like. So going through Oklahoma, Nebraska, and even northern Texas, you're going to see that there are a large number of tornadoes that happen every year. Now, I went down for spring break in 2017 and into Texas, and it was during tornado season. Tornado season typically is like February to July for them, and it was the normal. Tornado sirens were going off. People weren't frantically leaving stores or going to their basements. It was something that they were used to. It's not like here in Ohio where tornado siren goes off and everybody panics. So a typical cumulonimbus cloud has ice crystals near its tops. Sometimes these ice crystals act as a trigger to further growth of the cloud droplets, and because of this will form hail. Hurricanes and tropical storms. When winds are particularly strong, they become known by different names. These super winds are called hurricanes in the Atlantic Ocean, typhoons in the Pacific, and cyclones in the Indian Ocean. So a hurricane is an intense tropical storm with winds that exceed over 119 kilometers per hour. If it is not over 119 kilometers per hour, then they typically call it just a tropical storm. And then blizzard is a violent winter characterized by freezing temperatures, strong winds, and blowing snow. All right, so that concludes the podcast. Remember, at any point you could have paused this, rewind, make sure that you made a note of the different things that I said throughout this podcast. So that concludes it.